Hey, good day folks. Today I'm coming to you in HD because I'm using a different laptop. Now, I decided that I want to do one more C programming video before I move on to a different topic. And for today, I want to explore shadow headers. It seemed like quite an interesting topic to finish off this trilogy. Now, to demonstrate the utility of shadow headers, I'll be using some dynamic arrays. So before we jump into shadow headers, I just want to do a little bit of housekeeping. So first of all, last time I didn't introduce a run build target. Now what I want here is I just want to say make run, and then it should build the application and run it. So it's going to look very much the same as our test run target, except this one's going to be run and it will depend on the application. And once the application is built, it will run it. The second thing I want to do is I just want to clean up the main file because it's got a lot of leftover code from my previous video. So we won't need any of those or that. Now, if I type in make run, what I would expect is that it will build the application and it will run, returning 0 as a success status. So I'm going to start with a simple static array example that I'll modify to demonstrate shadow headers and dynamic arrays. So for this, what I want is an array variable that I'll initialize to the first 5 numbers on my keyboard. Now what I want to do next is I want to loop over the elements in the array and I want to print them out. So the way to do that is we just have a boomer loop with an index counter starting at 0. The index counter needs to be less than the length of the array, and we want to increment the counter at the end of each iteration. Then I'll just do a simple fprintf to standard out. And I'm going to use the following pattern where I've got the element at a given index equals to a value. And we'll supply the index counter and the value of the array at that index. Now, next what we need to do is we need to find the length of the array. Now, through inspection, we can see that this should be 5. But I want to use C's built-in functions to work out what the length is. So we can say that the length of the array equals to the size of the array. So that's going to return the size of the array in bytes. And we want to divide that size by the size of the first element in the array, which would be an integer. Righto. Now, just to make sure that it calculates the right value for the length, I'm going to print out the length as well. So we've got another fprintf to standard out. And this time I'm going to say that the length equals to some value Okay, now in this case, the size of will return a value of size type. So that's an unsigned long. Cool. So now we can run the application. We can see that we've got our length of 5, which is as we expected, and it prints out all the elements. Okay, so that was pretty easy. Let's make it a little bit more difficult. In most applications, we may have multiple functions, and we may want to pass those arrays between functions. So what I'll do now is I'll move all this logic that we have here to loop over the array and print out values into its own function. And we'll pass the array through as a parameter. Now the editor's already warning me that there's some problem here, but let's build and just see the full compiler error. Okay, what it's telling me here is that the size of the array parameter will effectively return the size of an int pointer. And the reason for this is that when we pass the array into functions, we're not making a full copy of the array. We're passing in a pointer to the array to that function. And as a result, the size of a calculation will not return the size of the array that we started with, but the size of a pointer to that array. So for now, what I'll do is I'll just fix it with a hard-coded value. So instead of having all the size of calculations, what I'll say is there will be some array length function that will accept the array as a parameter, and then it will return the length of that array. So let's define that function, and it's just going to return a size type and then of 5. So now if we rerun the application, we get the output that we expected. So to calculate the length of an array, we need to attach metadata to the array pointer. And the way we do that would be with a shadow header. Now the shadow header can be represented by a simple structure. So I'm going to create my structure. And in this case, I'll give it one field, which is the length field. And then let's just call this the array header. Now, in terms of the memory layout, we want the array pointer to point to the start of where the array's data is. And then immediately before the start of the array's data, we would want to have the array header. Now, that will allow us to find the array header if we just have a pointer to the start of the array's data. So for example, we can create this function to extract the array header. It will receive the array pointer as a parameter, and then what it will do is it will cast the array pointer to a array header pointer, and then it subtract 1. So that means from the array pointer, subtract the size of an array header, and that's going to put us at the start of the shadow header for the array. Now, in terms of how this impacts our array length function, what we can now do is we can call the array header function, pass through the array, and then we have access to the length field. Now let's give this a run, and what I would expect is that it will fail because we've got an illegal memory access. So to fix that memory access violation, there are two things we need to do. So we need to make sure that we've got enough memory available for the entire structure. And the second thing is we need to get that memory in the expected layout. So let's just start by converting our static array example into a dynamic array example. So we will no longer have this integer array variable. Instead, we'll have an integer pointer variable. And what I'll do is I'll just initialize that to a null pointer value. Now, to allocate memory on the heap, we need to call some standard library function. In this case, I'm going to call calloc. So calloc's going to allocate memory on the heap, and it will set that memory to 0 values. Now what it expects, the first parameter need to be the number of objects we want in this memory location, and the second parameter will be the size of those objects. So let's use size of, and then I'm going to dereference the array pointer. Now typically this could cause a segmentation fault or a memory access problem, but size of is a built-in function, and all it's telling C is that we want to get the size of whatever array is a pointer to. Now once we allocate memory on the heap, we would need to free up that memory. So for this we're just going to call the free function and pass through the array pointer. Now if we just work with a simple dynamic array, this is all we need to do. But in this case, we have this shadow header, so we need to increase the memory allocation to also have enough room, enough space for the shadow header. So I'm going to change this. I'm going to say that I just want one object. So it's going to be 5 times the size of the integer or the elements in the array. And it's going to also have enough room for the shadow header. So the size of the array header. Okay, now at this point we've got enough memory, but the array pointer, we want that to point to the start of our array data, and at the moment it's pointing to the start of the entire memory block. So what we need to do is we need to do the reverse of what we've got here in this array header function. Okay, so the array pointer equal to, now we need to have this cast to a void pointer because void pointers can be casted automatically to any other pointer type. And then before this cast, what we're going to do is we're going to cast the integer pointer to an array header pointer. Okay. Now we need to offset by the size of one array header, so it's going to be +1. Righto. Now the second thing we'll need to change here is now array is no longer pointing to the start of the memory block, it's pointing to the start of the data block. So we'll need to call this array header and pass through the array pointer as a parameter. Also, we said that we want to have 5 elements in this array, so we need to initialize the field of the header to have a value of 5 as the length. So let's just call our array header with the array pointer as a parameter length, and we now set that equal to 5. Okay, let's give that a run. Cool. Okay, so that's giving us the expected output. Now, this is something we would potentially want to reuse in other applications as well. So instead of having all this code in our main function block, it would be good to have some utility functions that we can just take with us from one project to the next. So the most simple one that we can extract here is we can have a array free function. So that's just going to be define array free, taking the array as a parameter, calling the standard library free function, and then calling array header, passing through the array as a parameter. So let's just get that. Righto. Now the second one that we want to extract is we want all that in an array initialize function. Now so far, all these macro functions that we defined are single expressions. So we now need to define a macro function that's got multiple statements inside the expression. So the way to do that, we're again going to define the function. It will take the array pointer as a parameter and then the length of the array that we expect. Now, to make these multiple statements look like a single expression, I'm going to wrap it inside a do-while loop. So the do-while loop is a single expression, but inside this block we can have multiple statements. So this is do-whiles, it's a reverse of a typical while loop. So everything inside this do block will need to be executed exactly once before the condition of the while is evaluated. So it's going to execute everything in there, then it's going to come to the condition of the while, see that it's false, and then it's going to exit. Now what this allows us to do is to call all of that like a single expression or a single function. So in this case, array init array, and we pass through a length of 5 with the semicolon at the end. Now we need to move all this inside our macro function. Okay, now the way we can have multiple line macro functions or macro definitions is we need to have a backslash at the end of each line. Okay, the other thing also, because these parameters can be expressions, what I would typically do is I would put the parameter inside parentheses so that the entire expression gets evaluated and resolved to a value before I attempt to use anything with that parameter. So the same over here. And of course we need to do put the arrow also in parentheses. Righto. Cool. So there we've got quite a simple main function implementation, and what we need to do for future projects is it's only that block that we would need to take with us. Anyway, let's give it a final run before we end this video. Okay, all good. So there is something that I forgot to mention. Because all these functions are macros, the array type is not limited to a specific type. So what we could have here is we could have let's make this a char string type, and we can just init that as well. And when we're done with it, and we can keep on doing this with as many different types as we want, even our custom structs. And when we build it, it's just going to run fine because there's no type information in the macro function definition. Now, for a truly reusable dynamic array data structure, there are some other functions one may also want to implement. But this is already quite a lengthy video, and the main goal for today was just to demonstrate shadow headers and what their utility is. So I'm certain once you've got those concepts down, implementing the remaining functionality of a dynamic array should be quite easy. Anyway, thanks for watching this video. If you like this video, click on the like button. If you want to see more, subscribe. And I'll see you in one of my next videos. Ciao.